Very good morning, friends. Myself, Dr. M.H. Annaya. In today's video, we are going to work out a problem on the development of a pentagonal pyramid. And the question for today's video reads as a pentagonal pyramid of side of base 30 mm and height 70 mm. The dimensions of the pyramid are given. Rests on HP on its base with a side of it normal to VP. So friends, we have to write the top and front views of the pyramid, keeping one of the edges or the side of the base normal to VP. So friends, I am going to construct a pentagon A, B, C, D, E. Here O is the center of the base. O1 is the center of the base. O dash represents the vertex of the pyramid. The height of the solid is given to be 70 millimeter. So we will be able to construct the front and top views of the pyramid to the given dimension, that is 30 millimeter side and height is equal to 70 millimeter. Then friends, what happens? A baby spider, a small animal, baby spider, starts its travel or starts its journey from one of the corners of the pyramid. So, if I take this D as the corner, the spider or the baby spider will start moving from this corner. It goes around the lateral surface of the pyramid and comes back to the starting point, taking the shortest route. So friends, to draw its path traced in the top and front views, we need to know the development of this pentagonal pyramid. Friends, here the line O dash D dash in the front view represents the true length of this slant edge. I will call it as TL because in the top view, the corresponding top view, that is O dash C dash O comma D, is parallel to VP, and this will give you the true length. And using this true length, I am going to write the development of the pentagonal pyramid. You know the procedure. I take this as point O, the vertex, and the starting point I will start from D because it is starting the journey from here. So here friends, you are going to have 5 sides. 1, 2, 3, 4 and 5. So I am going to join all these to the points on the base. So since this is a pyramid friends, I am going to join all these by straight lines because the pyramid has straight edges. And we'll call this A, B, C, D. E is the last point. E, F, G, H, and A. H is not there. It is lost is D, A, sorry, A, B, C, D, E is last. A, B, C, D, E. Then after E, A, B, C and D, because starting point and the last point should be same. Friends, this represents the development of the pentagonal pyramid when it is not cut by any section plane. Now friends, there is a baby spider which starts moving from the corner D, say, it goes around the periphery by the shortest route and reaches the end or the starting point D. So friends, we can assume that it is starting from this point D, and this is point number 1 we will call. 1 is the starting point, and that can be represented by 1 here at D, again 1.1 here. Now, friends, what is the meaning of shortest path traced by the pyramid? That is the shortest distance between any two points or any two stations is this straight line joining those two points. So, friends, I am going to just draw a line connecting D and D. Friends, this D and D is the shortest route followed by this baby spider. So, this is how it's going to move. Now, friends, all these edges, OD, OE, OA, all these five slant edges of the pyramid are true in length. And now the spider is moving from this point D, goes on to this OE, then to A, then to B, B to E, then comes back to this point. So it is going to start from here, then go to this C, sorry, D. This is this. Okay, C. From there it moves to this point A and B, then comes back to E, returns to the starting point A. Now we have to transfer all these points where the path of the spider is touched by these slant edges. So, friends, while moving from one to this point, say this point is 2 on OE, A, B, C, D, E, OE. Okay, we'll take this point on OE. So OE is here, that's O dash, E dash. So it will start from here and then it will go up to this. So I have to just transfer this distance on OE, that is 2 to E. 2 is to be marked on OE. Friends, but this is not the true length. So I am going to mark that point somewhere on this true length, shift that to the corresponding slant edge. That is, this is the point on OE. So we call it as this point 2. 2 is on OE. So friends, I can just write a vertical line from there and locate this point 2. This is 2. Then friends, this is going to move to point A from there. From this, it is going to point A. So on OA, mark this distance 3 or 3 to A. 3 to A on OA. So from here, friends, OA is also not the true length. So I am going to mark the distance here. Shift that to OA. True length is marked on this, then that is transferred to the true length line. So this is the point. So it has moved from there to this. So it has started from 1, it has moved to point 2, from 2 it has moved to this A, that is point 3. So after reaching that 3, friends, 1, 2, 3, 4, 5 have got, then again on OB it has got the same distance on OB. OB is here, so point 4 is going to come here on OB. So you can get those 2 points here. 1.3 is on OA. I can just write a vertical line from there. This is point 3, and similarly on OB you are going to get the point 4 because they will be at the same height. You can observe from this development. This is point 4. Then friends, after going to this point 4, it touches this slant edge OC on OC. So friends, OC is here, so it is traveling on the other side. So this is going to be point 5. So 2 and 5 will coincide, 3 and 4 will coincide. Only this you will have the separate point. So you are going to have one more point here. Now friends, if you want to see in the top view, let's see how it starts. It starts from point 1, moves to OE. So I am going to join O to E. This is the path traced like this. Then from 2 to 3, then from 3 to 4, 4 to 5, and again it returns to the starting point. So starting from D, it is going to touch this OE, then this, and this comes back. So this is the path, that is 1, 2, 3, 4, 5, 1 is the path traced by the baby spider in the top view. Similarly here friends, 1, 2, that is it will start from the corner D, it will move on to this E, point 2, this A, point 3, then it will come to point 4 on the same height, 3 and 4, it will come back to the starting point. And friends, this is 1, 2, 3, 4, 5, 1 is the path traced by this in the front view. So we are able to draw the front and top views of the path traced by the baby spider while traveling from a point on the other corner of the base of the pyramid, going around the periphery, that is a lateral surface, and returning to the starting point following the shortest route. So shortest route is this DD. Friends, I hope the presentation on this particular problem was interesting. Please go through the complete video without fail, and if you like this video, please share this information about my videos with all your friends. Thank you very much for watching my YouTube video. Have a wonderful day.